Alright, today we're going to talk about section 11.2, rational functions. Basically all we're going to do today is figure out where this, if I would graph it, where it won't exist, or where it would approach. And those things are called asymptotes and excluded values. And so your objective today is to be able to find those places. Excluded values come simply from when the denominator can't equal 0. So if you recall and you think about this, you can't divide by 0. So therefore, if you make the bottom or the denominator 0, you would have a hole in your graph. So in our first example, we have y equals 5 over 2x. So what has to happen is this part cannot equal 0. So I'm going to make it equal 0 and then see what would happen, what value I would get out when I do that. So I have 2x equals 0, which actually can't happen, but that's how I'm going to figure out what my excluded value is. And basically an excluded value, if I would graph, would create a hole in my graph. So for something, if I would graph something, let's say, this is not this example, this is just a general example, it'd be something like that, but there would be a hole somewhere over here, and usually we denote that with a circle. So I'd put a circle in the middle. Okay, so if my excluded value is, let's say, 1, so if I do this process, I get 1, my graph will have a hole right there. Anyway, back to our example. So I take my bottom, my denominator, and I make it equal to 0. I just need to simply solve for x at this point. Sometimes you need to factor, sometimes you just need to solve. In this case, we just need to solve. Those would cancel out, we're left with x equals 0 divided by 2, which is 0. So really, instead of saying it equals 0, x cannot equal 0. That would be your excluded value. X cannot equal 0. Right. On to the next one. We have y equals 4 over 3x plus 9. Really, the 4 is not important for us. The only way that would be important is if it was a 3, then I could simplify this down a little bit. But either way, I can still take this and make it equal to 0, the denominator. 3x plus 9 equals 0. Simply solve for x again. So there's multiple ways you can solve for x this time. I'm just going to take it step by step. Excuse me. 3x equals negative 9. Divide by 3, x equals negative 3. But really, x doesn't equal it. X won't equal negative 3. Okay? So those are excluded values. You take the denominator, you set it equal to 0, and you solve. If there would be extra things added on, you'd have to solve all of them. So if there's multiple parts to this question, you just solve each individual piece. That's an excluded value. Next we have something called an asymptote. And that's basically a line that your graph can't cross. So I have this form up here, y equals a over x minus b plus c. And the asymptotes will be at b and at c. Notice that the b has a negative or a subtraction in your equation. So it's always going to be the opposite when you go to find out what your asymptote is. What this is going to look like if you would graph. So if I make a little graph, basically it would be something like this. I'd have a graph and it would come up, but it would never actually hit the x-axis or whatever the number is. So that would be my asymptote right there. It would be x equals 0. Just for an example. So you have options, and basically what we're doing here is you're finding a whole excluded range of numbers. So in that last one where we had that hole, we could draw a vertical line, and everywhere that that number would hit, you would have a 0 or an excluded value. Same idea, right? We're doing x minus b equals 0. Solve for that, you get a positive b right there. So let's go to our examples. Our first example, I'm going to use this part. I need the opposite of that. So instead of positive 2, I need x equals negative 2. That would be one of my asymptotes. So I'd move over 2 on the x-axis, draw a line straight up and down. My other asymptote is whatever this number is, which is positive 1. So my other asymptote is at y equals 1. So just as a quick example, if I were to graph this, I would need x equals negative 2, so I would go back to right here, well, close to there. I would have an asymptote, and y equals 1, I would have an asymptote, so something like that. So your graph is going to not hit right there at some point. So it may go like this, it may be up here, it could be in these back two, but whatever's happening here, it will not hit those green lines. And it'll get really, really close to it, but it won't actually hit. And that's a good thing to know, because you know where your minimum profit is, or your maximum profit is potentially, using asymptotes. This second example, if we notice x doesn't have anything down here with it, so if there's nothing down there, I could really go plus 0, negative 0, or positive 0 is the same thing. So one of your asymptotes is at x equals 0, like our first example that I drew up here. And your other one is at y equals negative 2, and that comes from there. Those are asymptotes. You found excluded values. Basically, it's just the places where the graph can't touch or won't touch. You should be able to do this just fine now, and if you have questions, let me know.